Hello everyone. Today I will introduce the paper Improving the Fairness of the Min-Max Game in GANs Training, which has been published in WACV 2024 as an oral presentation. I will introduce this paper from 4 parts. First, I will introduce the motivation of this work. Second, I will talk about the proposed method. Then I will introduce the experiment results, and finally I will show the conclusion. Let's start with the first part, motivation. Generative adversarial networks (GANs) are well-known generative models that have achieved great success in recent years. However, the understanding of the min-max game in GANs training is still limited. To better comprehend the min-max game in GANs training, we apply information theory to GANs and reveal that the min-max game in existing GAN methods is unfair during training, leading to suboptimal convergence. To improve the fairness of min-max game in GANs training, we introduce a novel GAN called Information Gap GAN IG GAN, which enhances the fairness of the min-max game in GANs training and achieves better performance as shown in the bottom figure. Next, we will introduce the proposed method. We first analyze the unfair min-max game in existing methods by applying information game theory. We mainly analyze 3 types of GANs: original GANs, GANs with multiple discriminators, and GANs with augmentations. We conclude that in all these 3 types of GANs, the generator, G, obtains incomplete information while the discriminators, Ds, always obtain complete information during training. This indicates that the min-max game in these 3 types of GANs is unfair. This unfair min-max game can lead to suboptimal convergence during training. More details of theoretical analysis can be found in the main paper. To improve the fairness of min-max game in GANs training, we propose a novel GAN called Information Gap GAN, IG GAN. The overview of IG GAN is shown in this figure, which consists of 1 generator, G, and 2 discriminators, D1 and D2. Specifically, we applied different data augmentation methods to D1 and D2, respectively. The information gap between different data augmentation methods can change the information received by each player in the min-max game and lead to all 3 players, G, D1 and D2 in IG GAN obtaining incomplete information, which improves the fairness of the min-max game, yielding better convergence. Due to the applied augmentation types in IG GAN consists of 2 cases, i.e., IG GAN with negative data augmentation NDA in D1 and positive data augmentation PDA in D2, IG GAN NDA plus PDA, which is shown in Figure A, and IG GAN with different PDAs in D1 and D2, IG GAN PDA plus PDA, which is shown in Figure B. For IG GAN, NDA plus PDA, we use hyperparameter lambda to balance the NDA data and fake data, and we directly apply the PDA to both real and fake samples as in diff augment and ADA to avoid the leaking of augmentations issues. For IG GAN, PDA plus PDA, we also directly apply the PDA to both real and fake samples to avoid leaking of augmentations. The reason of designing IG GAN in 2 cases are shown in the table. Directing apply NDA in style GAN 2 can achieve worse performance, higher FID scores on FFHQ and LSUN CAT datasets. This indicates that NDA cannot effectively produce out-of-distribution samples on style GAN 2. In this case, applying NDA in style GAN 2 cannot bring the information gap. IG GAN makes that all 3 players in the min-max game obtain incomplete information during the training, effectively improving the fairness of the min-max game in GANs training. Then we follow the proofs of NDA to show the convergence of IG GAN in theory and demonstrate that the changes in information for each player do not influence IG GAN in reaching the Nash equilibrium in both cases. More details of the theory can be found in the main paper. Next, we show the experiment results of IG GAN on 2 backbones, style GAN 2 and big GAN with several different datasets. This page presents the experimental results on big GAN with several datasets. Firstly, we introduce different GAN settings for the experiments, as shown in the top table. It consists of 5 different GAN settings for a fair comparison. The results on several datasets with these different GAN settings are shown in the bottom table. IG GAN, NDA plus PDA, achieves better performance on the big GAN backbone. To further demonstrate the superiority of IG GAN, we also compare it with other state-of-the-art methods on unconditional and conditional CIFAR10 datasets. The results on the unconditional CIFAR10 dataset are shown in the left table, and the results on the conditional CIFAR10 dataset are shown in the right table. IG GAN, NDA plus PDA, achieves the best performance. We also present the results of IG-GAN on CIFAR 10 and 100 datasets under limited data settings. Following the experiment settings in diff-augment paper, we select 10% and 20% CIFAR 10 and 100 datasets to train the model, and the results are shown in the table. It is clearly that compared with other state-of-the-art SOTA methods, IG-GAN achieves comparable results. We also demonstrate IG-GAN on the StyleGAN2 backbone. Since NDA fails to produce out-of-distribution samples on StyleGAN2, we only apply different PDAs case 2 in IG-GAN to improve the min-max game. The results are shown in the table, and IG-GAN achieves better performance. We also compare IG-GAN with the similar method GENCO on FFHQ and LSUN-CAT datasets. IG-GAN achieves a considerable improvement compared to GENCO on the FFHQ-1K and LSUN-CAT-1K datasets, as shown in the top table. The compared generated images are displayed in the bottom figure. IG-GAN achieves better image quality in the generated images. In this paper, we unveil a new viewpoint on GANs training, showing that the min-max game in existing GANs is unfair. We hope this insight can guide future research in this area. To address this, we propose a novel GAN called IG-GAN, which improves the fairness of the min-max game in GANs. However, IG-GAN still cannot make the min-max game in GANs completely fair. We encourage future studies to focus on understanding the min-max game in GANs and proposing better strategies. Our code is available at the provided link. Thank you.